Hello everyone, my name is Tony Gualdron and today I will talk to you about an article called The Magnetic Structure of the Solar Wind, Ionic Composition and the Electronic Strahl. What is electron strahl? I will define what a strahl is for the people who do not know it. A strahl is the electron component of the solar wind that is the most closely aligned with the magnetic field of the Sun. These electrons are part of the high-speed component of the solar wind and have sufficient velocity to escape from the electrostatic potential of the Sun. They carry the electron head flux of the solar wind and always move away from the Sun, along the magnetic field lines. After listening to the previous title in the presentation, the following question arises: why is the magnetic structure of the solar wind of interest? The magnetic structure of the solar wind is of interest for various reasons. The structure impacts the behavior of the Earth's magnetosphere. The structure alters the behavior of interplanetary shocks. The structure affects the acceleration and transport of energy particles. The structure may carry information about coronal processes. This article has two main objectives. First, determine if there is ionic composition structure of the solar wind plasma corresponding to the magnetic flux tube structure. Second, determine if the intensity of the electron head flux from the Sun, the electron strahl, differs from the flux tube to flux tube. This will be determined by collecting the times of clear sudden shift in the value of the alpha to proton number, density ratio, and clear sudden shift of the value of the strahl flux, and then determining whether this time statistical coincide with flux tube walls, strong current sheets. The flux tube structure. The flux tube structure of the solar wind is seen most clearly by the change in the magnetic field direction as the structure advances past a spacecraft, like image in the left. The statistics of the angular change in the magnetic field direction of the solar wind at one astronomy unit is examined in figure on the right. For 11 years of the solar wind measurements by the Advanced Composition Explorer (ACE) Magnetic Field Experiment (MAC), the distribution of the occurrence will be fit by the sum of two exponential functions. Exponential 5 degrees denoting the distribution of the small angular change, and the exponential 20 degrees dominating at the large angular change. This is interpreted as two populations in the solar wind. Large change in the field direction occurring across the flux tube walls, and wiggles in the field direction occurring within the flux tube. Relation between alpha to proton number density ratio, ionic composition structure of the solar wind, and the magnetic structure. In the figure, the blue and red curve is the superposed epoch average of the change of the magnetic field direction every. At the times when alpha/p suddenly jumps zero on the horizontal axis, the magnetic field direction ends to undergo a strong directional change, consisting with the location of the fluid's two walls. Away from those alpha to proton number density radio sudden jumps, the change in the field direction are much more modest, consistent with the small magnetic field fluctuation in the interior of the flux tubes. The fact the location of the alpha to proton number density radio sudden jumps are consistent with the high probability of the occurrence sheet is the demonstration that the helium abundance is organized with the magnetic structure. Relation between the electron heat flux structure of the solar wind and the magnetic structure. The relationship of the location of the jumps in the intensity of the Strahl flux and the location of the current shifts is examined. In figure, the curve is the superposed epoch average of the change of the magnetic field direction every 60 seconds. The curve has a similar interpretation. At the times when Strahl intensity suddenly jumps zero on the horizontal axis, the magnetic field direction tends to undergo a strong directional change, consistent with the location on the fluid's two walls. Away from those sudden jumps of the Strahl intensity, the changes in the field direction are much more modest, consistent with the interiors of the fluid tubes. Analysis: if the fluid tube boundaries seen at one astronomy unit in the solar wind were formed at the Sun, it is easy to see how they could coincide with alpha to proton number density radio boundaries and Strahl boundaries. The magnetic field in the different fluid tubes connect to different locations of the Sun's and the fluid tube boundaries and the one astronomy unit connect to magnetic separatories on the Sun where the magnetic foot point location diverge. The different locations of the Suns produce wine with a different helium abundance and a different Strahl intensity. If the fluid's two boundaries set at one astronomy unit were created in situ by process in the solar wind away from the Sun, the explanation of their collocation with ion composition boundaries and electron heat flux boundary is less straightforward. The differential flow associated with magneto-hydrodynamic turbulence in the solar wind could cleave blocks of plasma to produce such boundaries. However, one consequence of such cleaving process would be a mixing of the solar wind plasma with the blocks begin constantly cleaved into smaller and smaller chunks of the plasma with the age of the solar wind. An analysis of the plasma chunk size distribution between 0.3 and 1 astronomical unit found no such shock size evolution, rejecting the notion that there was cleaving and mixing of the solar wind plasma by the action of turbulence. Thanks for listening to this information talk.